Welcome back to the Cosmic Code, where we crack the universe's secrets one physics problem at a time. Today we will examine projectile motion, aka the OOPS arc. Oh, buckle up, because today we will be launching in. So, you throw stuff, you launch rockets, you try to throw a crumpled piece of paper into the trash can, and you miss every single time. Now, this may seem like a cruel trick by the basketball fairy punishing you for your basketball sins, but no. It's all math. Now, by the end of this, you'll understand all of it. You'll understand perfect throw, or you'll understand how to launch a rocket into space. Yes, we're going that big. Now, this isn't just about throwing things. It's about controlling gravity itself, or warping it to your will. Now, does that sound dramatic? Well, you haven't seen anything yet. Okay, so projectile motion is basically just an object moving in two directions at the same time, horizontal and vertical. But here's the secret sauce. Those two motions are independent of one another. So, look here at this. When an object moves in horizontal direction, it lands at the same time as a vertical direction. That's pretty mind-blowing, right? Here's the specifics. Gravity really doesn't care about your horizontal motion. It's going to pull everything down in the same way no matter how fast you're moving forward. So, if you throw a ball in an arc, which you almost always do because we're not perfect, you combine the two demos to create one smooth throw. When calculating an object in projectile motion, there are actually only a few equations we need to know. So we'll start off with projectile motion because it's pretty simple. The equation we can use to find this motion is x equals vt, where x is the horizontal displacement, v is your velocity, and t is your time. Now, we only need one velocity because velocity for horizontal motion is constant. There are no forces acting on it that we have to worry about. So that makes everything a little easier. But you can't just whip that out of nowhere. No. You need to derive it.
Start with the kinematic equation x equals x initial plus vxt plus 1/2 axt squared. Next is simple. Just cancel things out. For example, x initial is just 0, so ignore that. Then there is no acceleration when considering horizontal motion, so ax equals 0. And that whole last part cancels out, leaving x equals vxt.
Next up, vertical motion. For this, we actually have acceleration, but don't worry. It's just 9.8 meters per second squared, or g, which is your force of gravity for Earth, and we are on Earth, so we use that as our acceleration. So, when you're trying to find your vertical displacement, or how high up you go, use the equation y equals v initial t plus 1/2 gt squared, where y is your vertical displacement, v initial is your initial velocity, which is how fast you start throwing, and g is your gravity, and t is your time. So deriving this equation is real simple. Use the same equation you used for horizontal motion, just switch all the variables to y for the height, and simply cancel out the initial displacement because that is where you'll be starting off, which is 0. So you can just cancel that and you're already there. Real simple. These two equations basically cover all you need to know. Just know the velocity for horizontal motion is constant and the vertical velocity is equal to v initial plus gt, which that's simple to derive, so I will not go much into it. Just use your first equation from your sheet and switch the a to g. So, with the equations we got, we can solve for specific values in our demonstration. Let's start simple, solving for our velocity in the horizontal direction. For this, we can manipulate the equation x equals vt to solve for v, making the equation v equals x over t. Both values can be easily found by measuring how far the ball went horizontally, which you can use a meter stick or a ruler, and just timing your simulation, which for us, let's say our distance was 6 meters and our time was 2 seconds. So, plug it into the equation, 6 over 2, which gets you 3 meters per second as our velocity for the horizontal direction. Now this is only a demonstration, so this will not be real in real life. And this is only for the horizontal direction, so this is not for the vertical direction. For that, we need to get to the vertical component. For the vertical component, simply use the equation Vy equals Vy initial plus Gt. For this, you need your initial velocity in the y direction, but since we threw it from rest, that is 0. Now, using the known equation Vy equals Gt, simply multiply 9 times 8 meters per second squared. We'll round up, of course, to 10 for this demonstration. And the time which you got in the air, which would be the same for the horizontal component, which would be 2 seconds. Multiply that out and you get 20 meters per second for the horizontal velocity, or the vertical velocity, my mistake. Now, we simply have to combine those two velocities to get the total velocity for our simulation. Now, we have to combine them using the Pythagorean theorem because the velocity is a vector, and you have two values that are perpendicular, making a right triangle. Now, plug it in, and you get the square root of horizontal velocity squared plus vertical velocity squared, which gets you your maximum velocity before the impact. Solving that out, you get 20.224 meters per second squared. Meters per second. Of course, this is only an experiment and would be different in real life, but for AP Physics 1, this is a great understanding of projectile motion. And there you have it, projectile motion decoded. From missed trash can shots to space travel, it all comes down to understanding how objects move through the air. Remember, horizontal and vertical motion are independent. Velocity is a vector, so use Pythag, and gravity is the ultimate equalizer. It doesn't care how fast you're moving horizontally, it pulls everything down at the same rate. Now that you've cracked the code, you're officially in control of the OOPS arc. Next time you take a shot at the basketball, throw a football, or even watch a rocket launch, you'll know the physics at play. And hey, if you ever feel like physics is working against you, just remember, you now know how to make it work for you. And that's pretty cool.